Hey, hello. This session is going to be a revision of probability distribution, which is Learning Unit 6, I believe. Okay, so let's begin. I'm going to share my window, and I hope the audio is okay. All right, so I'm going to cover this or revise this learning unit by looking at a question from a past year paper. All right, so let's look at the question on the left. So you can ignore what the numbers are exactly, but the first question, 2.1, here the score obtained on a maths exam is normally distributed with an average score mu of 56 and a standard deviation sigma of 11.25. So the question is, what is the probability that a randomly selected person will obtain a score between 55 and 58? And it also asks you to interpret the answer. Okay, so what they're telling us is that the exam scores follow the normal distribution. In other words, if we had to draw the distribution, it would be a bell-shaped curve. Okay, so I'll just start sketch on the right here. Okay, so on this horizontal axis, you have the scores for the exam, and I'll let that be X, so that's your scores for the exam or exam score. Right, and this distribution is centered at mu, which is given to us in the text. It's 56. 56, right, and it has a sigma, a width of 11.25. All right, and the question asks us to work out the probability that a student will score between 55 and 58. Between that, so 55 is on the left of 56, so I'll place it here, 55, and then 58 is on the right of 56, so it's here. All right, so what they want us to do is work out the area between these two values, and that'll give you the probability of scoring between these two marks. All right, so I'm going to shade that in different colors, and I'll explain why a bit later. Okay, so this part, the area between 55 and 56 will shaded blue. Okay, and then the area between 56 and 58 will shade that green. And so if we work out the green area and the blue area, and you add it up, and that'll be the answer. Okay, that's ultimately what we need to do to solve question 2.1. All right, so we need this green area, and we need this blue area. All right, and then we solved it. So all we have to do is add them up. In other words, what they're asking us to work out is what is the probability that X lies between 55 and 58. Right, now you could have less than equal to, and that doesn't really make much of a difference for the normal distribution. Remember, continuous distributions, it doesn't matter whether it's a greater than equal to or less or strictly greater than. All right, so in other words, this would be the same thing as if I did this. It wouldn't make a difference. Okay, all right. So now we want to solve this, and now in order to solve this, we don't have a table for exam scores, for specific distribution of exam scores. But we do know that this is normally distributed. We know that this curve here, it's normally distributed. And because of that, we can convert it to a Z-score and then find the probability, because we do have the table for the Z-score. So as long as anything is normally distributed, we can always convert that to a Z-score, and then we can use the normal distribution for the z-score in the back of our book. So in other words, we are going to convert it to an equivalent z distribution, z-score. So now instead of x on the axis, we have z. And that is going to be centered at 0. So the equivalent of the 56 is going to be 0. It's the same shape as the distribution above, but you have to convert these values to the equivalent z value. So what is the equivalent z value for 58? And what is the equivalent z value for 55? Okay, we got to find that. In order to do that, you use the equation z equals x minus mu all over sigma. Now that equation is given to you, you don't need to memorize it. All right, so we know our mu, that's 56. So mu is 56. Sigma is given to us as well, 11.25. So any x value you give it, it'll give you the equivalent z value. So for instance, for this 55, if you want the equivalent z value, then you plug in 55 for x. So you'll have 55 minus 56 over 11.25, and that will give you a value of minus 0.09. All right, then you do the same thing for the other x value, 58. This x value is 58, so now you're going to plug in 58 here instead. So 58 minus 56 all over 11.25 will give you the equivalent z value of 0.18. 0.18. Okay, so we know what the equivalent z values are, and so now we need to work at the same area that was given above, but there's the shaded region. So the blue region here is the same thing. The size of this blue region is exactly the same as the blue region above. Okay, and then the green region is the same as above as well. May not look exactly the same because I did a sketch by hand, but you can take my word for it. If my drawing was better, it would look exactly the same. All right, so we can find these areas. So the area, the green area, that's the area from 0 to 0.18. All right, so I'm just going to make some space here. Okay, don't need this anymore. Okay, this green area, right, this green area here, if you look at the Z table in the back of your book, all right, you can find the area from 0 to any Z value. Okay, so in your distribution table in the back of your textbook, you'll find the value for the green area is simply, you just kind of find the area between 0 less than Z less than 0.18. Right, because you're going from 0, see here, 0 to 0.18. So the table in the back of your book will give you the area for any Z value on the right of 0. And in this case, 0.18 is on the right of that. So if you look at that table and you pull out that probability, you'll get the value of, I'll tell you now, it is 0.0714. 0.0714. Okay, now that's the green area. Now the blue area, okay, now your Z value is on the left of 0. Okay, so you have a negative value. So your table doesn't give you the area for any Z value on the left of it, but you can use the property of symmetry. Okay, so remember symmetry. Let me kind of highlight what I mean by that. So I draw this graph here like that. In other words, here sensitive 0. If you want the area from 0 to negative 0.09, so you wanted this area here, it would be exactly the same as the area from 0 to positive 0.09. It would be exactly the same because of symmetry. They are the same. This area and that area are the same. All right. So using the same idea, remember I want this area here. Okay. So to get that area from my table, I simply find the area from 0 to positive 0.09, and that's the blue area. So that would be probability of 0 less than z less than positive 0.09. And that in my table is 0.0359. Okay, so now we have the green area and we have the blue area. We just add them up. So we add these two values up, and that's the answer. We add them up. The total area is 10.73%. That's your final answer. And the question says, interpret your answer. So you do need to provide a statement, otherwise you lose a mark. So just remember that. You can just simply say the probability of the student obtaining a score between 55 and 58 is 10.73%. Okay, you need to write that out. All right. Okay. Remember to provide a statement when they say interpret your answer. Okay, so that's 2.1. Now let's move on to 2.2. Okay, 2.2 says, it has been found that 1 out of 4 people who visit a local store purchase bread. So I'm going to highlight this part because it's going to be important. 1 out of 4. Okay, so 1 out of 4, in other words, 1/4 or 25%, there's a chance of someone purchasing bread. Excuse me, having a drink. If we randomly select a sample of 9 visitors to the store, what is the probability that, let's look at the first question, no more than 2 of the visitors will purchase bread? And interpret your answer. That means provide a statement. All right, so we first need to determine what distribution are we dealing with for question 2.2. Now, if you look at the outcome that they're interested in is whether someone buys bread or not. So it's only 2 possible outcomes, and those outcomes are the opposite of each other. You buy bread or you don't. So in other words, binary outcome, 2 possible outcomes, which are the opposite of each other. And there's a total of 9 visitors. So there's a fixed number of trials or experiments, okay, which is 9, which are n. In other words, we are dealing with a binomial distribution. So for question 2.2, we're going to be working with a binomial distribution. Very important that you're able to identify what distribution you're dealing with, because if you get that wrong, then everything else that follows is going to be wrong. Okay, so it's a binomial distribution. And so with the distribution, you're going to be working with a variable called x, and you need to understand what that x represents. So what will give you an idea of what that x should be is look at the question. Okay, if they want to work out the chance of someone purchasing bread, right? And a specific number of people purchasing bread. So in other words, x is the number of people purchasing bread. All right. So in other words, what they want us to work for 2.2.1 is the probability that no more than 2. Okay, so that there can be a bit of a tricky, or what to say here, a challenge to identify what they mean by no more than 2. Okay, not that straightforward. So no more than 2 means you can have 2, but you can't have more than 2, right? You can have 1, which is still fine. You can have 2, that's still fine. You can even have 0, and that's still fine. But once you have something more than 2, then that's a no. So in other words, they want us to work out the probability that x is at most 2. In other words, less than or equal to 2, because 2 is included, right? You can't have 3, 4, 5. So they're asking us to work this out. This is the question, right? To solve this. Now to solve this, because you're working with x less than or equal to 2, that means everything from 2 and below. So you have to find the probabilities for all x values below 2 and including 2. So you can have the case where no one buys bread, so x can be 0. And you can add that to the probability of x equals to 1. And then you're going to add that to the probability of x equals to 2. Right? And you stop there because remember it's less than or equal to 2. So you include 2 and nothing above that. And you have to work out each of these probabilities using the binomial formula, which is given to you in your formula sheet. So in your formula sheet, this would be the equation. It's NCX e to the x 1 minus p to the n minus x. Okay, that's the equation you're going to use in your formula sheet. And the value for p is in the question, one out of every 4 people. So it means p is 1 divided by 4. There's a 25% chance that someone will purchase bread. That's what your p is. Okay, so your p in this example is 0.25. Or you can write it as 1 over 4. It's up to you. All right. Your n, there you go. It's the number of trials that you wrote earlier. It's 9. Okay, and your c is not really a variable. That's the function in your calculator combination. All right. So you'd be using this in your calculator. We've done this before. Please do watch the synchronous session again if you're not sure what do we mean by this C here. So watch the synchronous session on Learning Unit 6, okay? And I've also covered this for counting techniques, which is the section Learning Unit 5 on probability and counting techniques, all right? Okay, so first one we're going to work out is probability of x equals to 0. So we're going to use this equation for that. So that this value here, we work it out using that equation. So we're going to substitute n. We're going to substitute 9 for the value n, which is 9. C, and now x is 0. Okay, so 9c 0. P, which is 0.25. Okay, so remember it's this whole thing here times what's in brackets. This is p to the power x, which is 0, times 1 minus 0.25 to the n, which is 9, minus 0. All right, that's how you work at the first one. All right, you punch it into your calculator and get a value. If you do that, you'll get a value of 0.075. All right, okay. Then you're going to do the same thing for the next one, but instead of x equals to 0, you are going to have x equals to 1. So you're going to replace the 0 with a 1 and the 0 here. Wherever you see x, you're going to replace it with a 1. All right, and when you do that and you put this into your calculator, you get a value of 0.2253. And then lastly, you got to work out this probability here, probability of x equals to 2. So now remember, instead of x equals to 1, you're going to put x equals to 2 in this equation. Okay. And then you will get a value of 0.3003. And then you add them up, and that'll be your final answer. And that in percentage terms, it's 60.07%. It's almost 60%. All right. So that's your final answer. Okay, and then remember to interpret your answer. To interpret it, simply just reading what the question is asking you to do. Okay, it's asking you what's the probability of no more than 2 of the visitors will purchase bread. So all you're going to say is the probability that no more than 2 of the visitors will purchase bread is 60.07%. It's as simple as that. Okay, whatever answer you get, just interpret it by providing a statement. Okay, all right. So that's 2.2.1. All right, so I'm going to just remove this. And then move on to the next one. So this answer is 60.07%. All right, now 2.2. Okay, using the same distribution, what is the probability that more than 3 of the visitors will purchase bread? More than 3 means probability of x greater than 3. Right? We need to solve this. Now, x greater than 3 means x can take on the value 4, x can take on the value 5, 6, 7, 8, and 9. Now, if I have to work at the probability of each of them, that's 1, 2, 3, 4, 5, 6. Excuse me. Those are 6 probabilities I got to work out, and that might take a lot of time. So remember, in the exam, you are pressed for time, and you need to find ways to do things more efficiently. All right. So instead of doing it that way, which is perfectly fine, but just understand it will take you a lot of time. All right. Instead of doing it that way, I'm going to use the complement rule to be more efficient. Okay. So instead of working that out and taking all the values above 3, I'm going to use the complement rule and say 1 minus the opposite of this. 1 minus the opposite of this, which is probability of x less than equal to 3. All right. Okay. Now, so to work this out, this is simply, I'll write this in the next line. It's 1 minus. Okay. Now, this is the 1 minus that I wrote down here. Everything that's in the square brackets is this part here. So that's the probability of x equals to 0 plus the probability of x equals to 1, etc., all the way till probability of x equals to 3. All right. Now, if you look at everything here before the probability of x equals to 3, that's x equals to 0, x equals to 1, and then the missing part here is x equals to 2. Right? And if you look at the question before that, you'll see that you've already done that. You've actually done that work. So there's no point in actually working each of these probabilities again, because you've done all of that. So this entire term here that I'm highlighting, we've already done it. And that is this value here. So I'm going to remove this part here. Okay. I don't need to work at everything again. That is simply just 60.07%. So this is another way you can be more efficient. And you can speed up the reduce the amount of time you spend on questions. Okay, so I'm just going to rewrite this a bit bigger here. Conclude here. x equals to 3. So there's only one probability I need to work out now. It's only one, which is this one here. All right, so that makes it a lot easier. Right, so I need to work this probability out, and I just use this formula here, like I did before, with n equals to 9, p equals 0.25. But now the x that I'm going to substitute in this equation is going to be 3. Because if you look, that's the probability I need to work out. X is equal to 3. So I'm going to do that, plug in 3 into this equation with p equal to 0.25 and n equal to 9. And if you do that, then this value here is, and please, I encourage you to work this out as well on your own. Okay, try this problem out on your own and see if you get the same answer. That becomes probability 0.2336. 0.2336. All right. All right. So then the final answer is just working all of this out in your calculator. Okay. So remember, this is 60.07%. If you want to write it as a decimal, because everything is a decimal, I'll just do that here. Make it. It's up to you. You don't have to write it as a percent. I'm going to write it as a decimal. So everything in the square brackets is a decimal. You don't get confused. So it's 0.6007. Right? Or you can write it as a percent, like what you have here. It's up to you. So I'll work everything out here. 1 minus, open bracket, 0.6007 plus 0.2336, close bracket. And if you work that out, your final answer will be, I'll write it out here on the left. Okay, this whole thing here is equal to 0.1657. So that is 0.1657. So how would I interpret it? Well, question 2.2. Remember, the question is, what is the probability that more than 3 visitors will purchase bread? So all I need to do is write it in words. Simply just say the probability. Well, let me just change the color. Okay. I'm just going to write it, yeah, with the freehand. Okay, so the probability that more than 3 visitors will purchase bread is this value here. You can write it as a percentage if you want, or leave it as a decimal. Right, both would be acceptable. All right, so that is Learning Unit 5 revision. Sorry, Learning Unit 6. All right, I haven't covered the Poisson distribution here, but please do cover that because that is also likely to come to your exam. All right, please do give it a shot. And if you have any questions, just let me know. All right, that's it for me this evening, and all the best with revision, everyone. Thank you for joining. Have a good evening.